Okay, so let's get started. We're going to be taking a look at our VCT scheduling once again in this training module. We're going to be focusing on snap to point and snap to line programming, understanding what role they play in the VCT scheduling. It's actually going to be relatively simple to understand. I'm going to use some visual aids here in this tutorial so you can see exactly how things are implemented. Now, the VCT scheduling is based on statistics and probability. We learned in the last tutorial taking a look at our VCM scanner at some log data. Looking at the map points, we saw that there is a weighting percentage as we start to rotate the cam and it moves through the various map points. It can draw a weighting percentage across various different map point tables and within the VCT scheduling. So this is going to be expanding on understanding how the snap to point and snap to line fit into that weighting percent factor and moving throughout the VCT scheduling. So this is important to understand if you want to do custom VCT programming, so schedule programming, if you want to go in and command your own cam pairings and being able to write your own custom schedule for whatever vehicle you're going to be calibrating and tuning, whether it's a Mustang or an F-150. Let's say you come up with a custom turbo kit or some kind of a unique supercharger kit, and you want to go in and have a specific VCT schedule. You're able to accomplish that, but you have to understand the snap to point and snap to line programming. So first thing we want to do here is open up a stock equivalent file in HP Tuner's VCM editor software. Let's do that right now. So we're going to go up here to File, Open. I'm going to go open up the same file I've been working with in the last few tutorials, 2019 Mustang GT manual stock. Let's go ahead and open that up. And then we're going to move over here into our engine, and then we're going to go over here under the airflow tab over into variable camshaft. Now, while we're in this particular tab or page, we want to open up a few different tables so we can take a look at a few things and understand what's going on. So the first thing we want to do here is open up our intake valve opening and exhaust valve closing tables. So we see both of those are open. And then we're also going to be opening up our snap to point and our snap to line. So let's go ahead and get all those open, and let's close then our window here. So we have this kind of in a cascading type of layout looking at all of this, going from our intake valve opening map points, our exhaust valve closing map points, and then we have finally our snap to point, and then lastly we have here our snap to line. So the way this is going to work, and the best way that I can describe understanding the snap to point and the snap to line, is that this is going to be calling out the allowed travel and the points where the map points can essentially snap themselves to in an XY plotting grid system. This might seem kind of weird right now. It'll make a lot more sense once we start to take a look at some visual examples here later in the tutorial. But what we can find here, if we're looking at our snap to point, is that we have zeros or ones in here. A 1 means it's enabled at a particular map point. A 0 means it's disabled. What this is saying is that anything that has a 1, as we're traveling through all of the various map point configurations, let's say we're in the distance tables, we might be in fuel economy, or we might be in the best drivability, we're going to be calling out different cam pairings, different map points to travel to. In the traveling or the movement of that variable cam pairing in the map points XY space, these snapped points are essentially, you can treat these, the way I like to think of these, as a magnetic point. We're going to be able to snap to that mapped point. Again, this will make a little bit more sense as we're going to look at some visual examples of actual XY plot and understanding how this all fits in. Then we have a snap to line. This is going to be providing a guidance in the travel throughout the XY space. So when we're traveling from one map point to another, we want to be able to define a path for movement. This, again, the way that the VCT scheduling is based on, it's statistics and probability, and it's going to be based on weighting factors. And this is all based on an XY plotting and grid system of our mapped points. Again, all of the different number map points and the cam pairings. We'll find that this defines the path of movement throughout the XY space. That's our snap to line, and the snap to point defines whether it's able to snap to a particular mapped point as it's traveling through the XY space. Again, this might seem a little bit abstract. Let's break this down further so we can see things maybe a little bit more clear. The next thing I want to do is jump into the VCM scanner. We're going to be opening up a sample data log that I've captured from our stock test demo vehicle so that we can analyze this a little bit further and understanding the influence of our snap to point and snap to line. What I'm going to do is move into the scanner right now. I'm going to go up here to log file open. And then in our, let's go to our desktop. Let's go here to our HPT Gen 3 Coyote folder. We're going to go into our sample data logs folder and then go into our VCT schedule sample data logs. We have a data log in here called VCT driving log. Let's go ahead and open that up. That's what we're going to use for this tutorial for demonstration purposes. So we can see in this data log here, we have our PID logging channel list loaded over on the left here. If we go down, we're going to notice that I'm logging every single mapped point and our VCT schedule mode, as well as our desired and actual intake and exhaust cam movement. This is important for understanding how this all fits together. Now, I want to also point out two additional things that we have to make sure you have open in your VCM scanner. First thing I want to take a look at here in the scanner is going to go up to tools, going up into our math parameters. You want to make sure in your first user math here, we can see right now I have this in. Let me go actually close this out and bring that math channel in. We want to bring in a math channel that's going to transcribe the 0 to 100% movement of our intake manifold runner control, also known as our charge motion valve assembly. So we can actually see how that's moving, assuming that you have your intake manifold runner control still active and present on your vehicle. You want to be able to see what's going on with that, because we know we move through the map point scheduling. Map points 0 through 13 are assigned to intake manifold runner control closed, so the valve closed, and then 14 to 26 is assigned to the valve open. So we need to track this and keep this as a math channel, as a parameter that we can use as an overlay here into our template. So let's take a look at that real quick.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.